Hello, Chemistry 11. This is Mr. Chan, and today is sort of the last, this video is the last lesson of the solution chemistry. And this builds upon last day when you did the dilution and dissociation equations, dissociation questions. Now, recall when you're mixing two solutions, what you have to do is you have to find the concentrations, the final concentrations of each solution. And then you apply that concentration to the dissociation equation. Now, this is pretty straightforward. And what I want to do right now is I want to show you a challenging question, which sort of kicks it up a little bit. So if we look at the challenge question, this is something similar. It says here, a 0.6 liter of an unknown concentration of barium nitrate was added to 0.25 liters of 0.1 molar aluminum nitrate solution. The final total NO3 minus 1 was 0.450. What was the initial concentration from the barium nitrate solution? Now, the first thing is you might say, oh my gosh, Mr. Chan, this is totally difficult. How does it apply to last day? So what I'm going to do is I'm going to show you. So the first thing is one key word here is the unknown concentration. Okay. Now, using your math skills, remember unknown concentration. This is X. Now, notice it says barium nitrate solution was added to another solution. So in this case, when you see the word was added, what you have here is you could say, dilutions. So you need to use the M1 V1 equals MF VF. Now you can try this question right now, see if you can figure it out, and the answer should be around 0.512. Now, if you had paused the video for a second, you can try it out and see if you know where to start it and where you can sort of try to figure out the answer. All right, so you can pause your video right here and try to work to get the answer of 0.512. All right, welcome back. Now, some of you might say, oh, this was difficult. So how do you approach it? So basically, the first step is you want to use dilutions, okay? Now, but the key thing you will notice is this. When you do your dilution calculations, you still do the MI/VI equals MF/VF, but notice the initial concentration I placed as X, okay? So for the barium nitrate, when I was trying to find the final concentration, final molarity, notice I had the variable X in the equation, and that represents the unknown initial concentration. Now, secondly, I did the dissociation equation. So notice what I did was I did the dissociation equation. So what I did was I broke apart barium nitrate into barium and 2 nitrates. And then I broke apart the aluminum nitrates to aluminum and 3 nitrates. Notice what I did was I doubled the concentration of nitrate and I tripled the concentration of nitrate from aluminum nitrate. And I doubled the concentration of nitrate from barium nitrate because of the mole ratio. Now, so you should understand how did I get the 1.412x and the 0.087. Now, this is what you had done from last day. So last day, when we did our question here, we did the dilutions and then we did the dissociation. Now, what is the third part to this? Notice these are both nitrates. So the question said, the final total concentration of nitrate was this. So since there was nitrate from both barium nitrate and aluminum nitrate, if I combine the two, what I can do is solve for single variable. And then what I do is I solve for x. Now, notice here, I solve for x. X is 0.257. But because barium nitrate breaks apart into two nitrates, then I had to multiply the concentration of the 0.257 by 2 to get an answer of 0.514. All right. So what you can do is take a look. Are you able to understand the process? Okay. All I did was I just took the dilutions and dissociations from last day, but instead of straightforward numbers, I just added a variable x. And then the last one is where it was sort of the next level. All right. Hint, 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 hint. On your solutions test, you might get a question similar to this, where you have an unknown variable x that you need to apply in the question. Okay. Now, what I'd like to do today for the very last bit is talk about the last thing with solution chemistry is precipitation and net ionic equations. Now, recall, when two solutions are mixed, generally a double replacement reaction occurs and an insoluble solid forms and separates from the solution. Such a reaction is called a precipitation reaction, and the solid that forms is a precipitate. Now, what do I mean by this? So what you have is you have two solutions, and when you mix those two solutions together, in this particular scenario, notice you have a yellow cloudy substance. This yellow cloudy substance that's being produced, this is what we call the precipitate. In other words, it's a solid is formed. Okay. Now, this occurs in majority of double replacement reactions. So, for example, let's say we have potassium sulfate and barium nitrate. What are the products? Now, you remember back in chemical reactions, these are double replacement reactions. And so what you get is a product is KNO3 and BaSO4. Now, recall from chemical reactions, when you were predicting products, remember you have to check the solubility table for double replacement reactions. Okay, so remember you had to use, go back to solution chemistry. Let me see, we have it here. You had to use the solubility table. Okay, remember what does soluble mean? What does low solubility mean? So using this table, recall you get to predict whether one will be soluble or dissolves, and while the other does not. So in this case, using the solubility table, you know that KNO3 will dissolve. So what we will do is we will put, in this case here, the phase symbol AQ, which means it dissolves, and BaSO4 would be the solid. So in other words, what happens is if we get the reaction and we see that there's something cloudy, BaSO4 would be called the precipitate. Okay. Now, when we have double replacement reactions or solution reactions, there are three different ways to write it. So we have three ways to write. Okay. Now, the first way is called the molecular equation. So what you have is basically like what we wrote, from grade 10, grade 11, where you write the equations K2SO4 and BaNO3 and you would get the balanced equation of KNO3 to KNO3 AQ and BaSO4 solid. Okay. That's called the molecular equation. We've done this a lot. Okay. Now the second one is called the complete ionic equation. Okay. So what would be the complete ionic equation? Would be breaking apart all the substances into their ions because they're all ionic solids. So what I would have is I would have 2K plus and SO4 minus 2 ions plus barium plus 2 and 2 NO3 minus 1 ions would give us 2K plus and 2 NO3 minus 1 plus BaSO4 solid. Now, one thing you will notice is that with the BaSO4, notice it stays solid. No ions. Why? Is because it does not break apart. All right, it doesn't break apart into its component ions, it sticks together, and this is why you don't have, it will stay as a solid. Okay, now there is this little link, preparatorychemistry.com/precipitation. What I will do is I'll put that in the description. You can click on it to sort of see why some ions or some solids will dissolve in solution, just like the KNO3, while the barium sulfate or other ones do not. Now, no ions, you could say here, stay solid. Okay. Now, one thing you will notice is this. Notice the potassium. The potassium ions and nitrate ions don't seem to change. So in this case, the ions that don't change, so in this case, 2K plus and 2NO3 are called spectator ions. Because don't change in the reaction. Okay. Notice they start off as ions in the reactant. They end off as ions in the products. And so because they don't change, it's called spectator ions. Now, the last one, the third one, is called the net ionic equation. I say N, I, E. Complete ionic equation, sorry, would be C, I, E. The net ionic equation involves ions that react aka chemical change. So in this particular case, it would be barium plus 2 plus sulfate minus 2 gives you barium sulfate solid. Okay, that would be the net ionic equation for this reaction. Now, a couple of things about the net ionic equation. For chemistry 11 only, what happens is you have ions in solution. I forgot to put that here. So you have AQ, AQ, and what you'd have is you have them forming a solid. Okay, but in reality, you could have ions in solution forming a pure liquid. An example would be something like water. You have H plus AQ and OH minus 1 AQ would give you water as a liquid. That would also be a net ionic equation because what you're doing is representing the ions undergoing a chemical change. But in chemistry 11, all you need to focus on is the ions that form a solid. Okay. Now, some of you might say, is there only one net ionic equation? And the answer is no. There could be 2, there could be 3. Sometimes there could be none. If there isn't a chemical reaction, if there are no ions that react, then there's no reaction. So it all really depends right back here in the original equation. Is, in chemistry 11, is there a precipitate? Yes or no? And what you have to do is you have to check the products. You need to check the solubility table for each one. And that will determine what are the spectator ions and what are the net ionic equations that are part of this reaction. All right, folks, that is it. Thank you very much. Have a good day. Bye-bye.